Okay, so the experimental setup for this lab, each group should have 2 setups. So they're going to have 2 of these tubes that they're going to put the plants in. And they'll have 2 of these, the little pipettes shoved through the rubber stopper, okay? And lab tech, make sure we have enough of these or we'll have to make some more. And then they're going to need 1 large beaker, which is going to serve as their water buffer for the sunlight, for the light. And then just 1 small beaker that they can hold their experimental setups. They actually might want 2 of these small beakers if they're going to do 2 different things with their setups. They may not actually need that. Okay, so what they're going to do is they're going to have Elodia. Now this is where we're going to use the bulk of our Elodia. So feel free to have a whole beaker full of Elodia plants on each table so that the students have plenty of space for these. All right, so they're going to take the Elodia and they're looking for the greenest parts, and our Elodia's, it's still green. So what they're going to do is they want it to be about halfway up the tube, so I'm going to cut some of these off so we're not quite so long, and actually it doesn't hurt to stuff every available piece down in there. We want a good chunk of Elodia in each one of our test tubes. So I've got Elodia in there. And then our second setup, I'm just going to cut this in half and put them both in there. We just want as much green as possible. Okay, so there's my 2 setups. Once they get those in there, and you might tell them to go wash their hands immediately because the Elodia actually has some little critters living in it. And then there's going to be a stock solution of sodium bicarbonate. It's 3%. Okay, that means that if you run out, you can make more. It is 3 grams in 100 mils, or 30 grams in the 1 liter bottles. Okay? And so if you run out, TAs, feel free to make more. There's a little scale in the back. Just dump into a little weigh boat, 30 grams, pour it into the glass bottle, fill it up with water from the sink. Okay, but there should be plenty of this stock solution available. So each student is going to fill their little tubes from the stock solution so that the plant is submerged. Okay, so you can see that. Can we see? Okay, plant is submerged. Okay, so once they've done that, and we want it as full as possible because we want the smallest amount of air in there to make differences in the plant. So then you're going to cap them. Oh, this one on the top. This is not making me happy. Hold on a second. So maybe not too full. What we want is for the water level to be measurable inside of the pipette. So that's going above like it is right here. We want to get it out because what you're going to measure is the change in the water up the pipette. Where's the level? These ones with filters are not making me happy. Okay, so when you cap them, there's my filter. There we go. So the ones with the plastic filter, lab tech, if we can get the cotton filter, if we get the cotton filter out, that's going to be a good idea. Okay, so I don't know if you can see, but I want to cap it not too tight, but tight enough that it's not going to move. Okay, now you can look here. I'm going to show you. I don't know if you can see this. Let me see. Can you see where the water level is? If I move this a little bit, you can see it. It's right there in my tube. Okay, so we want to be able to see the water level somewhere before the end of the tube. Okay, and so then the students are going to measure their initial water level. So they're going to measure from the top down to the water level. All right, so if I measure mine from the top down to the water level, my water level is at let's see, 109 millimeters is where my water level is, and on each of these. And this one, like I said, with the filter is being kind of goofy. but you measure it. All right, so they're going to record in their lab manual, they're going to record in their lab manual the millimeters, the starting millimeters and the ending millimeters. Oh my gosh. Actually, they're just going to have to do it on a separate piece of paper because there's not a spot on the lab manual. So they're going to start their starting millimeter height and the ending millimeter height after 10 minutes. So they need to get a baseline rate of photosynthesis for their two setups. And they should probably, with a wax pencil, label it setup A and setup B. Okay, and they need to fill their big beaker with water